I think I'm live now. Hello there everyone, my name is Peter Negi and I welcome you all to my channel. Today in this video we're gonna be talking about Creo Assembly and we're gonna learn how to do assembly with connections or joints so that we can make assembly with proper mechanism. And I am making this as a live stream because of the limited number of users, and this is the biggest challenge for me because as we know, like out of whole audience, how many are mechanical engineers, and out of mechanical engineers, how many are design engineers, and out of design engineers, how many are actually using Creo. So the audience is very narrow, and that led me to make these kind of videos like in the form of live stream, because the editing take a lot time to edit and post. But at the same time I think I am quite okay with live stream as well. So now let's talk about today's topic. So I was discussing about assembly with connections or joints. Now, the assembly having proper connection or have several advantages, as you can virtually check the functionality of your product, and also you can perform several type of analysis, for example kinematic and dynamic analysis, and that the dynamic analysis allow you to check for the different forces, and you can apply a different kind of forces in your model, for example coefficient of friction, or maybe you can enable gravity and can see how your model or how your product going to react. You can also do kinematic analysis, like you can calculate the distance or can measure a particular parameter. Not only that, you can also see check for the interferences, like when you can simulate your model, the working condition of your model, and you can verify like if your part have kind of interference somewhere, and then it allow you to recorrect your model before actually producing it or before sending it to the manufacturing. So it is quite useful. Here in this case we're gonna be talking about a single slider crankchain mechanism. This is one of the basic and I would say one of the most commonly used mechanism in the mechanical world, because every piston engine cylinder is basically a single slider crankchain, in which there is a crank which have a continuous rotation motion. The connecting rod have a kind of oscillation motion, and our piston make a to and fro motion, and the fourth part is the base, which is again fixed. I am expecting at least one online user so that I may feel motivated and will think my effort doesn't went in vain. You also can contribute to my channel, because as I told you, like the number of users are very narrow, the quantity. So you can support me in Patreon. I will be putting the link in the description below after this live stream, and you can also consider subscribing to my channel for this kind of video. Also you can comment in description down below if you want me to make a video in a particular topic, and most probably that gonna be a live stream, or maybe if the topic is small then I can make a video. So now, without wasting further more time, let's get started. So here you can see I just want to check for the sound. Just give me a moment whether the sound is coming or not. Just want to verify. I think the sound is perfect, so now we can begin. Okay, so here you can see our interface. I have already opened PTC Creo, And I just want to show you what actually the single slider crank chain look like. And I guess most of the mechanical guys, they already know what actually the single slider crank chain look like. So here you can see the mechanism, and this is our crank,
motion,
which having kind of rotational motion, and this is our connecting rod, and this is a kind of piston having to and from motion. I will just muting the sound, and you can see we will try to simulate the same condition. Here we can see this one is the pin joint, and here we have got the cylinder joint. Here it's pin and as well as cylinder. So ultimately we need to figure it out in terms of degree of freedom, and we will see how we're gonna make this happen. And here we have got the slider, which is again sliding inside the cylinder. Okay, so I don't think so we need to show this mechanism for a long time, because this is one of the basic mechanisms that we all know. Okay, most of us really find challenging in starting how we gonna make a kind of mechanism in Creo, because most of the time the new user, they don't know about the assembly with connection. Okay, so let's make the parts first, or we can start directly in assembly. I'm just gonna give it a name, single slider crank chain. And let's just choose millimeter Newton second, or maybe millimeter kg second. Okay, so now we are in assembly mode, and just to save time, I will just creating part inside quickly. I'm gonna give it this is gonna be a fixed plate in which we will be adding our parts. Okay, so I'm gonna give it a name, fixed plate, and again let me just choose the suitable template. Creo standard, no, not here, I guess here. PTC Creo common file and template, because this one here is inch, pound, second, and I generally work in millimeter kg, so I'm gonna choose this one. Now let it be as it is, and here is our first part. Now I have just created my first part inside our assembly with the help of this create tool, and we can create several more parts like this. Here we're gonna use not top down, bottom up approach. So let's create our first part. I'm going to activate it. When we activate our part, we are basically leaving the assembly mode and going inside the part mode. So right now we are in part mode. As you can see here, all our tools got changed to the part, because we have now this part activated and our assembly gray out. As you can see here, the plane, still we can take a reference, but we will try to avoid taking reference from the assembly. Now let's try to make our crank. Let's make this the screen parallel, the sketch parallel to screen. Now I'm gonna take a center rectangle and set the value of a crank to 300 and the width to 45. Let's add two rectangle here and smaller one. Let's make it 15. Let's make them equal. Equal and equal. Okay, let's just trim the extra part that we don't need. Okay, I'm gonna make it a very simple kind of block diagram because the final shape would take a lot time, and I'm doing it randomly, so I haven't got any uh, data available. Precise data I don't have. Okay, so it's a kind of crank. So I'm gonna, oops, I have created the part name as fixed plate, but I mistakenly create the crank. Okay, no problem. I'm gonna change the name because I guess maybe this is my second live stream and I'm sorry, but we can change the name. Okay, so I'm gonna give it a name like a crank, but we will change the sequence because of the reason, like the parent part should be the fixed plate. Okay, now let's create a fixed plate, but before that let's just save this part and assembly. So now I have saved the part in assembly and I'm gonna perform erase no displayed. Now let's create again fixed plate. Fix plate, and as we are working assembly, so you all I guess know like we cannot provide space, and most of the time we use underscore whenever we want to give some part a name which have more than one word. Then this is the normal way to do this. Okay, so part solid, again the same format, and this time let's try to make it large. Again we went inside this particular part, and now we will try to make it bigger. Let's select the center rectangle and try to make it large. If this does not fit as per our requirement, then we also may consider of changing the values. Now, as I told you, we need to make this parent. So for that, we need to drag the crank down and the fixed plate up so that we can constrain it as a fix or maybe as a default. The difference between fix and default constraint is that the fixed constraint frees the coordinate system at same place, while the default coordinate system matches the coordinate system of assembly and part. Now we're gonna hit OK because this is perfect for us. And this is our isometric view, and we can see we don't want it like this. So I will be just making some changes. Just updating my config.pro. Let's take this crank out, and I'm gonna modify this one. So the shortcut way is, without activating our part, is we can go here at filter and can select a feature, and now I double click on it and I can modify my feature. So here I think I'm gonna make it 1600 and this one 900. Then I'm gonna press Ctrl+Z, and here you can see we have modified our plate. Again, back to geometry. Now I'm gonna make some more modification to the plate. I'm gonna make a hole here. Making hole is pretty easy. Just click on hole tool and then select the surface where you want to place your hole. For example, here. This is already pre-selected and I haven't pressed any mouse button, and as soon as you press left button, your pre-selection turns green, which symbolizes that you have now selected. And you can also see the color of pre-select. So this is the color of pre-select, which is a kind of reddish. Not the whole reddish, it's a kind of orange, I would say. Okay, so again, hole, and this is pre-selection, and I will be confirming it by pressing left click. And now we need to provide the value to the reference collector. So let's make a right click and select the second option, which is offset reference collector. And now press Ctrl and provide two direction like this. Okay, so here we have taken our dimension as 12, so I will be making the whole size to be 8, maybe. Yes, we're gonna make it 8, and we can make it as a metric. $200. We can make other changes if required, and let's make it 2 thread. So we can use a kind stripper bolt or something so that we can hold or crank here. Okay, so the next thing we can add here is the bolt. So I will be creating a small bolt, and the bolt should have the dia of 12, I guess 15, sorry. I guess this one have, okay, both have 15, so no problem. What we can do is we can make it, okay, let's go to tree filter feature, and now I guess we can better select our hole. We have selected the hole, and again here I'm gonna make it bigger. M10 1.5 would be suitable with 2 thread. Also we can provide some chamfer, but here we are just making this mechanism, so not the practical, but I just wanted to show you, and you're gonna be using it in a practical project. Okay, so now again get back to bolt, and now here are the coordinate system of bolt, and okay, I will be making a bolt 14.95. I am choosing a random value, so don't think like I am making a standard bolt. No, I am choosing some random value. and there could be several procedures of making a bolt. Let's just check out the value of a 15 stripper bolt, or maybe we can have a look of M15 Allen bolt specs. Okay, images, Allen here. Okay, now here we can see. Okay, so it was kind of reference, so I will be keeping it as it is, like maybe 28, and here like this. Now let's try to fix this bolt here. Now as we know, the hole here is M10. Let's just check the thickness of this plate is 15, so I'm gonna make a 12 mm thread here. Let's use helical sweep, because for internal we can easily create hole, but for external we have to use kind of helical sweep. I don't know why, because in, for example, solid edge, we have options of deciding like which type of thread it is, and let's use helical sweep for this situation. Right click, define helical profile, and now sketch view. I'm gonna make it starting from outside. Let's define this as a start point, and I'm gonna take this as a reference and this as a reference. I'm gonna reduce this value to 15 or maybe 14.5, because I don't want my no, 13 will be good. I don't want my thread to be out of plate from other direction. Now again here it's 3. I am intentionally keeping it out so that when I will make a cut, the cut look quite clean. So let's make it 16, because this is gonna be 13 and the whole length of this line is 13, and this 16, sorry, and this one gonna be 13 because 3 mm is offset. Okay, and let's just define our center line. Center line. I hope you all guys know how to create this helical sweep. Now we already know the pitch for M10 is 1.5, and now time to create the profile. So I'm gonna make a metric thread, and we all know metric thread have got 60° of angle, and let's make it again 1.5, and okay, and let's just try to remove. Okay, so that's all right. Now let's create some kind of undercut here, and maybe we can also create undercut here as well. Okay, but for the time 5, let's create undercut of 0.5 into 0.5. Undercut really help bolt to go inside and fit inside properly. Because of the radius, sometimes it creates problem. So either we can provide undercut to our bolt, or we can provide chamfer to the plate where we are, installing or inserting this bolt. I'm gonna save this here again. Now let's just fix this bolt. here, and I'm using constraint, not the connection here in this case, because my bolt is not movable, so it is a kind of fix. Okay, so we have provided the axial constraint. Now let's just choose another constraint here. Let's make it -13. As we know, we have a thread up to 13 mm, and now we can see we have successfully inserted our bolt, and this one we have done using constraint, assembly using constraint, not assembly using connection. Now again, the bolt gonna be parent of this crank, so I will be again pushing this bolt up and crank down. Okay, now what we can do is, again, let's just go to crank and go to edit definition and choose the axis. Either we can choose the axis on cylindrical or the cylindrical part. I'm gonna clear it, and this time I'm gonna use connection. So I'm saying that this is a pin connection. Okay, and I have chosen this as the axis, this as axis. Now here, instead of fully constrained, you will see the status as connection definition complete, because in case of connection it may be possible like we do not have a degree of freedom, but in many cases we will have a degree of freedom. Some cases 2 degree of freedom, some cases 1 degree of freedom. For example, in this case of pin joint, we're gonna have 1 degree of freedom. So here you can see the connection definition is now completed, and I want this bolt to be like this. Even though I know like it's not practically feasible, maybe we need to insert some kind of bush here, and okay, let's just insert some kind of bush here so that it feels more practical. Distance from here to here gonna be 37. Let's just create a small bush. Should not be any kind of circular reference here. Okay, let's try to make this connection again. Axial alignment. Okay, let's try to flip the direction. I don't know why this is coming, because I guess this is completely okay, because these two are fixed connection and we already have make this one as a parent and this one is as a child, because I drag this down. Maybe we can see the bolt. For bolt also the parent is fixed plate. Okay, this generally happen. Now we can check our connection whether it is okay or not. To check our connection, just press Ctrl and Alt, and now with the help of left mouse you can try, and here we go. We can see we have successfully placed our first connection. Now we will see other parts, like for example connecting rod and the slider. Maybe we can change our position of this hole. Let's again go to feature, Make this one as 500, this one as 300. Control plus Z for update, and you can see. Now let's try to make a connecting rod. I'm just going to modify this one. Okay, so this was the reason of this. Circular reference. Let's add some point here, and then let's make it coincident from here to here. Okay, let's make it again. I don't know what's the problem with this one, because this extrude is not stable. Maybe he have taken some reference from outside. Let's delete it. I don't need any reference here. Like this one. Now again, sketch view, and we can make, let's take reference again. I really didn't remember the values, but I guess this was 300 and the width was 35 or maybe 45, and here was circle. Now again, let's take let me just make it 15 back, and because these two are equal, so it's gonna modify automatically. And you can also lock these dimensions to further increase the stability. And now you can see it is there is no problem, and there is no such external reference now with this extrude, and I hope now there will be no circular reference. As you can see, the circular reference problem went out, and here we have got the crank. It shows the crank have a problem, but in actual the problem we have already solved. Now just we need to fix this small issue. Which is I need to provide the reference again, and as it have just missed the axial reference, so I have provided axial reference back, and you can see all of the things are now properly placed. And again, you can check by Control and Alt, and also can use drag components. Okay, so now the next thing I'm gonna make is a slider. For slider, I will be taking again another block slider, and let's just place it as it is. activate, and now I'm gonna make it 150, 250, and the thickness to be 25. We will see like we can increase or decrease the value. Okay, maybe we can add bush as well here. So let's drag this insert here to up, and one more up, and I'm gonna add bush, which kinda make an offset between the bolt, which gonna make an offset to our crank. And here let's make it bush. And we already know the value was 15, so I'm gonna make it 15.1, and this value to be 25, maybe 45. Yeah, because the width of our crank is also 45, so let's make it 45, and the value we can change later on. As of now, I'm just making it 13 mm thick. Now it is quite simple because we're gonna assemble it as a constraint, so no more complexity and simple assembly. I just make this distance as a constant, and now again I'm gonna make the crank back, and now let's just calculate the distance between both, and it is 24, so I'm gonna add 24 to the width of my the height of my bus, and it's gonna be 35. So no, it's gonna be 37, I guess. Let's press Ctrl Z, and now you can see. Okay, again back to feature, and I'm gonna retry my slider back. So this is gonna be our slider, and before the slider, again we need a slider case. So I'm gonna create slider case, onto which the slider gonna slide and gonna perform to and from motion. Okay, now this is the coolest part of the Creo, or maybe in other software as well. Like, we can create part in assembly mode, and based on our other part we can make a modification. Now this one is 150. We can also create some kind of boolean operation to create our another part, because again we not want to face the problem of circular reference, because that part, the slider case, gonna be parent of the slider, so we cannot take reference of a slider. Now let's just make, we have already, now we have okay, now we have activated the slider case, and here already we have reference. Make the sketching plane parallel to screen. Again we're gonna take this rectangle and make this value 500, and this one again 350 for example, and again we're gonna be making adjustment if required later on, and the thickness to be 50. This is symmetric extrude. And okay, let's try to assemble it now. And I would like to match the center plane with center plane, and here the backside with the backside, and here again at the base. I can also use bolt. Just how we gonna fix this one? So go to tool and no, before going to tool, we need to create some kind of sketch here. Okay, so 200, make it 135, this one also 135, or maybe 145, 45, fine. This one also 200, and that's all. Now I'm gonna use tool and screw assemble on reference. Now let's just enable the point and select these points. Screw head gonna be this one, and this one gonna be nut or thread. Now I'm gonna use at least M4, and the bolt need to be Allen bolt or maybe button bolt, anyone. It's not required for this example, but I'm just using it. Okay, so it have made it M6, and let's add the counter bore as well. Now I don't want to make it through hole, and let the value be as it is. Oops, I guess I cannot use this feature because I'm using student version, and this part library is created with a commercial version, as you can see here the error message. But I guess you will able to do it. Oops, I guess the Creo app done its magic. Let's try to retry. Great. So we cannot use that assembly, and let's try to assemble these parts as fast as possible. Okay, I don't want to repeat the same things that I have already spoken. Make this distance minus 13 and crank. Okay, fine. Let's just make a bus as fast as possible because we have already done that. And here, because of this crash, again see PTC templates, solid part MKS. Again, same steps. 15, 45, and 5. I didn't remember the value, so I will be again assembling it. Let's make it up and let's make bolt as a parent for this bus. Now let's select the back here, constant. Again, let's just check the value. Oh, I remember it was 37, so let's go back again to feature and make it 37. Control plus Z to regenerate, and again geometry, and let me just save it so that again I will avoid the condition of losing my data. Again we have to make this slider part slider. Now this time I'm gonna make slider case first. Again let's make it center rectangle and the value to be 500 by 300, thickness to be 30, and let's make it symmetric. Now again I will try to assemble it as it was assembled last time. I don't want to make the delay, but sometimes, you know, the Creo crashes like it crashed. Although it was my fault because I'm using student version, and here we cannot access the commercial library. Okay, so let's just move the position of this one as well, the whole position, or maybe, yes, maybe we can change the value, make it 500, 300, Control plus Z, and now as you can see we have achieved what we wanted to. Now let's just create a slider cut. I'm gonna make it a rectangle, so let's take a rectangle. I'm gonna take center rectangle, not here. Oh, maybe we again need to take the references again and make sure while taking reference, like here we have chosen assembly top, which we don't want to take as a reference. So let's just verify and select the planes and the reference from the same part, and you can easily verify by seeing at the last. As you can see here, the slider case is written, which confirm like we have chosen the right reference. Okay, I want to choose the reference of the same part, which will minimize the problem of circular reference that we have seen previously. Now let's make this cut which we wanted to, because I am making this, I have chosen center rectangle and the half center rectangle is outside, so it's gonna make the half cut. Let's make it 150 and let's do all, and here you can see. Also, I'm not creating any kind of chamfer or any kind of deburring operation here because I just wanted to show you the connections. Okay, now let's create the slider part. Slider. and here we can see the dimensions that we have provided for slider. Let's measure the length. It's 150, and let's make it 150 by 150. Let's just try to find where the 150, 150, and 15, for example, and we will verify and can make a modification accordingly as per our requirement. And now this time I will be assembling it as a slider. Again, go to assembly with connection and choose slider as a reference. Now if you have any kind of confusion like which connection should I choose, then always see the taskbar or message bar or status bar, and what does it says here? It is asking us to choose the aligning axis on one part, so let's just choose the aligning axis, and here also. Now it is asking us to choose the planar component, so let's just choose the planar component here in the part, and same with the assembly. Now we can see here the connection definition complete and our part in orange, which also shows that we have successfully fulfilled the requirement of the connection. Now again, for that, to check this also, again we have this problem again, and let's just see again this got happen with extrude. This time let's again fix this up. Not gonna use any reference. Maybe I have chosen this. Again, let's just use coincident and coincident. Let's make another point here and coincident. Again, there is a problem. Let's make it 0. I guess now, okay, we're gonna add a point here and let's try to make we need to figure it out. Point on entity, no, vertical, yep. Now you can see our extrude is proper, and proper mean it's not it does not have any kind of circular reference. Again, press Ctrl Z, and our part is free. Let us examine again how it is working, and here you can see it is working properly. Now we need to make a hole on our part, and again I will be just opening it in part mode so that, you know, to avoid these kind of problems. Let's make it 250, and now let's just verify. Okay, the direction is right, and now again open the part and place a hole here. Let's make this distance 30 and 0 from the center, and this one again I'm gonna make all the holes of same value, so let's make a through hole here, and we can provide threading for this. Although it is not necessary for demonstration, but still we can make it. Okay, M10 and through, thread also through. Okay, now close it and you're gonna see. Now it's time to make a connecting rod. I'm gonna simply choose this one and save as. Let me just see the location of these parts. See public document, okay. Save as and save it as connecting. Now let's just change the value. Let's make it 600 and we will modify it according to our requirement. But we have modified the wrong item, I guess. Okay, so let's just go again feature and change the value to 300 back. And now we have saved our connecting rod as, and now we can import it here. Okay, so the thing now we have to do is we have to create a two connection, one with the slider which is gonna perform to and fro motion, and another one with this crank. So let's make a pin connection first of all, which is gonna be here and here. And you can see we have successfully created. You can also check this one. Now we need to make another connection with it. For that, again, let's go back. We even do not need to come out, and we simply can add new set, and this time we cannot choose pin, because if we choose pin then it would be nice like connecting these two parts, but when because we also need to provide a planar value. So we already have provided planar value here. So if we provide planar value at two places, so it's gonna make our connection over constrained. Therefore we cannot use pin here, so we need to use cylinder here. And as you can see here, we are successfully able to connect these both parts with connecting rod. And let's change the value of this connecting rod to 600 for example, and Ctrl+Z, and let's save this model again so that we avoid the situation of losing our data. And let's try to just color this with a different one so that you can easily identify the parts. Maybe you can select the metals. Okay, so now let's try to see how this mechanism is. And here we go, as you can see here. And now, as I told you, we can perform a different kind of test, for example interference. So we can go to application, and then obviously we can create animation as well, but not today. let's go to mechanism, and then we can use kind of motor here, and we can also apply force motor, but generally if you're gonna buy the simpler version of this PTC, then you cannot apply the dynamic analysis. And here I'm gonna do angular velocity test, function to be constant, and the value a here, let's make it 10 degree per second. You can also plot the graph like how it's gonna be. So it's gonna be constant with time, as you can see here. This is velocity versus time graph. You can check these points, and now you can see this one symbolizes the position. As you can see, with time our position changes, and this is the magnitude, and you can see our acceleration is 0 and our velocity is constant. Okay, so here we are now interested in running this small kinematic analysis. Now we already have set motor here. Now we're gonna go mechanism analysis, and here we can run, and you can see how our mechanism is running. And it was for a quite short time, so I can increase the value to 100, so that now this time I guess it will run more. And here we go. But here, as you can see, we are running mechanism, but it is not telling us whether our part have kind of fault, because I guess we haven't enabled the collision detection. Now for that we can enable collision detection settings. For that we're gonna click here, playback, and let's try to find out, or maybe here only it is the collision detection, and enable the global collision detection. And we also can enable the sound upon collision, and also can stop playing animation. But let's just try to perform again. Mechanism analysis, run. Okay, make it 100. So this is the whole animation. Let it got complete. I know, like, it is coming very out, but now because we already have now it is computing for interference, as you can see here, because we have enabled the collision detection settings. It is just for the display purpose, or I mean, I have just created a block diagram, so please try to ignore like why this is coming too much out, the slider, because we can set it properly by various way. We can increase the length of this slider case, or maybe we can decrease the length of our crank. So it totally depends on our situation and scenario. When we will make the tutorial of real machine, maybe in future, if I get the sufficient audience, then we're gonna take the real and practical values. Currently it is computing for the interference, as you can see here down. It will calculate up to 100 because we have given 100 as a value while in mechanical analysis. Now we're gonna see we can increase or decrease our speed, and it is showing us where is the problem. Obviously there will be, because here are the threads, but you see here, and during the collision detection setting I didn't wanted to stop the animation, so the animation is continuously going on even after detecting the collision. As you can see here, collision is being shown in red color, and we can perform so many tests like this. I hope guys I may able to tell you how you can do assembly with the help of connections, and there are so many other connections also available here, and this really help us to test our prototype or our part and simulate the virtual condition. As you can see here, the sound is also coming while interference. So by applying the proper connection, then only you can simulate the kinematic and dynamic condition. If, let's say for example, I do not use the pin joint, and let's just delete this one, and I use assembly by constraint, then it won't be feasible to run this analysis. As you can see, this time I used assembly by constraint, and I already have lost the link from this connection, and my part is completely destroyed. My connection or my mechanism is completely destroyed. So this is the advantage of using assembly by connection. So I hope again, I'm repeating the same. I hope that I may able to explain you the importance of connection, assembly by connection. If you have got any questions, queries, you can make comment. And I will try to reply you as soon as possible. And also consider subscribing my channel for this kind of video. And as I also told you, my audience is very narrow because of the designers and the Creo designers. So I'm going to target a very narrow audience. So consider supporting my channel with Patreon if possible. And I will see you soon in next video. Thank you and goodbye.